Hello grade 12s. This is the second part of your grade 11 revision, specifically looking at the probability identity, mutually exclusive events, independent events, and such. Okay, so the first one we need to talk about the probability identity. This probability identity is on your formula sheet. So on your formula sheet it says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And pretty much all that it really refers to is this. If I talk about the probability of A, and I color that in this Venn diagram, it's all of this right there. That's A. Then, if I add to that the probability of B, so I color in all of this because this is B, all of that, I have now added those 1, 2 spaces plus those 1, 2 spaces, which unfortunately, if I'm looking for A or B, so the union of A, B, I kept on saying this in the previous video, I can't double up. I can't add this up twice. And that is why I then get to subtract it once. So we're saying if I add those 2 spaces, and I'll just show it to you with text as well, probability of A means I add this one and this one. If I add the probability of B, I add this one and this one. But this has now been added twice. So that's why I need to subtract it once so that it's equal to the probability of A or B. So that's just your probability identity, very important probability identity. Okay, right, so next we have to talk about mutually exclusive events, complementary events, and then also independent events. Now, mutually exclusive events are events that literally have no intersection. Meaning, if I draw it in a Venn diagram, mutually exclusive events would look like this. There's event A and there's event B. There's no overlap. There's no intersection. So generally, if you have to prove or check whether something is mutually exclusive or not, you can do it in one of 2 ways. The first way is simply to say the probability of A and B, so the intersection, is 0. There's no probability of A and B. So because there's no probability of A and B happening, it means there's no overlap, so they are mutually exclusive. Or, if we go back to this probability identity, we can simply see then, if this is 0 because the events are mutually exclusive, then I can actually just cover that up. And that's the other way to prove that 2 events are mutually exclusive. If you prove that the probability of A or B is equal to the probability of A plus the probability of B, because the probability of A and B is 0, then that also proves that it's mutually exclusive. So either one of these 2 will be a proof that something is mutually exclusive. Or, if they give you the fact that the events are mutually exclusive, then you can go and you can use this in whatever calculations you need. Great. Complementary events. So if I talk about complementary events like the complement of A, the complement of A means the probability of A not happening. Now please remember, very important here, this is not on your formula sheet, you need to know this off by heart. The probability of the complement of A is equal to 1 minus the probability of A. Just like the probability of the complement of B will be equal to 1 minus the probability of B. So please, please, please remember this. And you can also rearrange it slightly if you want by saying that the probability of A will then be equal to 1 minus the probability of the complement of A. So it pretty much means exactly the same thing. Independent events. Now this is the one I used in the previous video that I said I will discuss again in this video. Again, this is not on your formula sheet. This is a definition you need to know. You either have to go and you have to, if it's given that an event is independent, if it's given that the event is independent, then you can automatically make this statement. You can say the probability of A times the probability of B is equal to the probability of A and B, like I did in that example in the previous video. I could make the statement because it was given that the events were independent. But if I have to prove it, so prove the events are independent, then it's different. I cannot start with what I'm trying to prove. Please remember, I will first have to work out the probability of A, then I'll have to work out the probability of B, and then I'll have to work out the probability of A and B. And then I need to prove that the probability of A times the probability of B is equal to the probability of A and B. So please do not mess up these two. If it's given, you can start with a statement, because independence is given, so you can start with an independent statement. But if you have to prove the events are independent, you can't start with this. You've got to end with this. You have to do these separately and then prove that this is in fact true. Okay, so this is pretty much the theory part of your grade 11 probability. We're going to do a couple of examples just on these mutually exclusive events and independent events. Now the first one says, events A and B are independent. The probability of event A happening is 0,4 and the probability of event B happening is 0,25. Now the fact that they gave this to you, they gave you the fact that the two events are independent right there, means you can start with this statement right there. We can start with that because it's given. I don't have to prove it, I can just use it. So I can go and say the probability of A and B is then equal to 0,4 times 0,25, because that's the probability of A times the probability of B. So I can then write that down. And that is going to be 0,1. Now this was important to do first, because I know the question said represent the information on a Venn diagram. But if you'd started with a Venn diagram without doing this part first, you would have realized you're stuck. Because I would have said there is event A, so that's going to be the probability of A. And there's event B, so that's going to be the probability of B. But remember, in Venn diagrams, we always start on the inside and work our way out. So if you tried to put that 0,4 in here, you would have realized 0,4 had to be split into two spaces. And I don't know what the split is. And that 0,25 also had to be split into two spaces, and I didn't know what the split was. But by using the fact that it was given the events are independent to work out the intersection, I can now put the 0,1 in here. And that makes everything so much easier. Because now this needs to be 0,3. So that 0,3 plus 0,1 adds up to the 0,4. That is the total A. And then this one needs to be 0,15. So that 0,1 plus 0,15 is then equal to the 0,25 over there. And then please remember that the entire probability must always add up to 1. So I can go and say 0.3 plus 0.1 plus 0.15 is equal to 0.55, which means over here I still need 0,45, so that these 1, 2, 3, 4 probabilities add up to 1. Okay. Now the next question then asks, determine the probability of A or the complement of B. Now careful, because or means the union, so it's everything that's an A, everything that is in the complement of the B, but don't add things up twice. So don't go and confuse union with intersection. The union is actually quite easy. You say, we color in everything that's an A, so all of that. Then we color in everything that is in the complement of B, so outside B, not in B. So that's all of this. All of that is not in B. But please remember, just because this one is colored in twice does not mean we add it twice. We're only allowed to add it once. But that means I add this one, this one, this one. I add all three of those because of the word union. If they had used the other one, intersection, I would have only looked at the overlap. Then it would have only been 0,3. But this one says union, so that's going to be 0,3 plus 0,1 plus 0,45. So I can add that. And that's going to give me 0,85. Okay, so that was the first example on these independent events. Now, the last example over here, they give you A and B are two events. Probability of A 0,4, probability of B 0,3, and the probability of A or B is 0,58. Now the first question they ask, are events A and B mutually exclusive? And explain. Now in mathematics, people, when you explain, you are actually required to explain it mathematically. In other words, you're required to explain it by doing a mathematical calculation. Just using a bunch of words is not enough. So I need to go back to that definition of mutually exclusive, and I need to do my calculations to understand whether it's mutually exclusive or not. So I start by saying, if two events are mutually exclusive, then we know that in order for events to be mutually exclusive, the probability of A or B must be equal to the probability of A plus the probability of B. Now please remember, we haven't been given that the events are mutually exclusive. We are trying to prove it. So that's why we have to keep it separate. We have to say the probability of A or B is given as 0,58. Whereas the probability of A plus the probability of B is then going to be equal to 0,4 plus 0,3, which is 0,7. So I can then go and say, therefore, the probability of A or B is not equal to the probability of A plus the probability of B, which means these events are not mutually exclusive. And this is your explanation. This mathematics that you did right there, that's the entire explanation. You can then just go and say, therefore, not mutually exclusive. Then the next one, are events A and B independent? Okay, let's see. Explain. And again, we are checking to see whether it's independent, so you can't start with a statement. So we first have to go and we have to say, okay, I need to calculate A and B. So in order to calculate A and B, I first need to go to the probability identity, because remember, they haven't given me A and B. And I can't use independence to calculate A and B. So I have to say the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is what I'm going to use to calculate that probability of A and B, because I've got the probability of A or B. It was given there as 0,58. Probability of A was given as 0,4. Probability of B was given as 0,3, which then allows me to work out the probability of A and B. By the way, this, whether the events are independent, whether they are mutually exclusive, it doesn't matter. This probability identity always holds true. And that is why you should know that the probability of A and B is always going to be equal to the probability of A plus the probability of B minus the probability of A or B. Okay, so that's a very nice thing to remember for these types of problems. So that means the probability of A and B here is then going to be equal to the 0,4 plus the 0,3 minus the 0,58. So that's 0.7 minus 0.58, which gives you 0,12. So now we still need to calculate the probability of A times the probability of B, so we can check whether these two are equal or not. So that's going to be 0,4 times 0,3, which is 0,12. So therefore, I can now make the statement that the probability of A and B is equal to the probability of A times the probability of B, because I've proven this, so I can make this statement. So, yes, they are independent. So these are the type of questions they can ask you about mutually exclusive events, complements, and independence. Thank you again for listening.